Imagine a time when humans marveled at natural phenomena without understanding their secrets. Lightning storms filled the skies with awe, sparks from rubbing objects felt magical, and mysterious forces seemed to govern the universe. A journey through the discovery of electricity. 600 BCE. Ancient observations. The amber phenomenon 600 BCE. Greek philosopher Thales of Miletus noticed something peculiar while experimenting with amber, electron in Greek. He found that when amber was rubbed with fur or wool, it attracted light objects like feathers and grains of straw. What he observed was an early form of static electricity. What was happening? Rubbing amber transfers electrons from one material to another, creating a buildup of electric charge. This imbalance causes the amber to attract small objects. Though Thales didn't understand the science behind it, this discovery marked the earliest documented encounter with electricity. William Gilbert, 1600. During the Renaissance, curiosity about natural forces grew. William Gilbert, an English scientist, expanded on Thales' observations. Gilbert studied the behavior of amber and magnets, coining the term electricus to describe materials that attract objects after being rubbed. He differentiated electricity from magnetism, laying the groundwork for future studies. Generating sparks. Otto von Guericke, 1660. In 1660, Otto von Guericke, a German scientist, built one of the first machines to generate electricity. His device consisted of a large sulfur globe that could be spun and rubbed. When Guericke brought his hand or a metal object close to the charged globe, he observed a spark jump across the gap. Guericke's experiments amazed audiences and demonstrated that electricity was not limited to amber but could be generated mechanically. 1752 Benjamin Franklin's experiment conducted one of the most famous experiments in history to prove the connection between lightning and electricity. He flew a kite during a thunderstorm with a key attached to the string. When lightning struck, Franklin observed sparks jumping from the key to his hand, proving that lightning was a form of electrical discharge. Franklin's experiment wasn't just a scientific breakthrough. It also led to the invention of the lightning rod, which protected buildings from lightning strikes. Benjamin Franklin's single fluid theory suggested electricity is an invisible fluid, with objects becoming positively charged when they have more electrons and negatively charged when they have less. 1780 Luigi Galvani and animal electricity. Luigi Galvani, an Italian physician and scientist, made an accidental but significant discovery that laid the foundation for the concept of bioelectricity. Galvani was conducting experiments on animal muscles and nerves, specifically focusing on the effects of electricity on biological tissue. In 1780, while working with a frog's legs, Galvani noticed that the legs twitched when struck by a spark of electricity. The legs moved as if they were alive, even though the frog was already dead. This discovery led Galvani to hypothesize that electricity was somehow linked to the nervous system, and that living organisms possessed their own inherent electrical forces, which he referred to as animal electricity. 1800, the birth of the battery. Alessandro Volta used discs made of copper, a metal that conducts electricity. Well, alongside copper, he used discs of zinc, another metal with different electrical properties compared to copper. Between the copper and zinc discs, Volta placed wet paper or cloth. The paper was soaked in salt water or acid, which acted as an electrolyte. This is crucial because the electrolyte helps facilitate the chemical reaction between the copper and zinc and the both ends were connected to compass, which caused deflection due to electricity generated. 1820 André-Marie Ampère, electromagnetism. In the early 1800s, Hans Christian Ørsted discovered that an electric current, flowing through a wire, created a magnetic field around the wire. Ampère set up experiments to better understand the behavior of electric currents and their effects on magnetism. He placed two long, parallel wires near each other and passed electric current through them. He observed that when both wires carried current in the same direction, they attracted each other, while if the currents flowed in opposite directions, the wires repelled each other. Michael Faraday, 1830s. Faraday moved a magnet inside a coil of wire connected to a current measuring device, galvanometer. observed that current was produced when the magnet moved but stopped when the magnet was stationary. Faraday's law of electromagnetic induction states that the induced voltage, or EMF, is proportional to the rate of change of the magnetic field. Enabled the invention of electric generators, which convert mechanical energy into electricity. Led to the development of transformers for voltage regulation. Forms the basis of electricity generation in modern power plants. Faraday's work made large-scale electricity generation possible, revolutionizing industries and everyday life by providing a practical way to produce and distribute electricity. James Clerk Maxwell, 1860s. James Clerk Maxwell unified electricity, magnetism, and light through his Maxwell's equations in the 1860s. He showed that electricity and magnetism are interconnected, forming a single force called electromagnetism. Imagine electricity and magnetism as two best friends who always move together. Maxwell's equations explained their relationship and showed how their dance creates light and other waves. His work revealed that light is an electromagnetic wave, along with other waves like radio waves and X-rays, differing only in wavelength. Thomas Edison, 1879. Edison's light bulb worked by passing electricity through a carbonized bamboo filament, which heated up and glowed due to incandescence. The bulb was enclosed in a vacuum, or inert gas, to prevent the filament from burning out due to oxygen. The bulb was part of a larger electrical system that allowed it to be safely used in everyday life. Nikola Tesla, 1890s. Nikola Tesla developed alternating current, AC, to solve the inefficiencies of direct current, DC systems, which lost energy over long distances. AC works by alternating the direction of electric flow, allowing electricity to be transmitted efficiently over long distances with minimal energy loss. Tesla's key innovation was the rotating magnetic field, which he used to design the induction motor, enabling smooth and efficient power generation without the issues seen in DC motors. He also incorporated transformers into his AC system, which could increase voltage for long-distance transmission and decrease it for safe home use. To sum up, 600 BCE, Thales of Miletus observed amber attracting small objects when rubbed, marking the first documentation of static electricity. 1600, William Gilbert coined the term electricus and distinguished electricity from magnetism, laying the foundation for future studies. 1660, Otto von Guericke built the first electricity generating machine using a sulfur globe, producing sparks and showing electricity could be mechanically generated. 1752, Benjamin Franklin proved lightning is a form of electrical discharge through his famous kite experiment. Invented the lightning rod for protecting structures. 1780, Luigi Galvani discovered animal electricity while studying frog legs, linking electricity to biological systems and introducing the concept of bioelectricity. 1800, Alessandro Volta invented the first battery voltaic pile, using alternating copper and zinc discs separated by an electrolyte, enabling sustained electrical flow. 1820, André-Marie Ampère discovered the relationship between electric currents and magnetism, forming the basis of electromagnetism. 1830s, Michael Faraday demonstrated electromagnetic induction, leading to the invention of electric generators and transformers. Revolutionized large-scale electricity production. 1860s, James Clerk Maxwell unified electricity and magnetism with Maxwell's equations, showing they form a single force and that light is an electromagnetic wave. 1879, Thomas Edison invented the practical light bulb, creating an entire electrical system for safe home and industrial use. 1890s, Nikola Tesla developed alternating current, AC, for efficient long-distance electricity transmission, transforming the energy industry. Designed the induction motor and transformer-based systems. From the ancient Greeks discovering the mysteries of static electricity to the groundbreaking experiments of Franklin, Faraday, and Volta, humanity's understanding of electricity grew step by step. Please do like and subscribe for more interesting content.